Okay, today we're going to graph one of these, actually. We're going to graph number 17 over here. Okay, you may or may not be able to recognize this, but this is actually a parabola. Okay, we can tell it's a parabola because it only has one squared variable. Okay, now right now it's not in the standard parabola form. So in order to do that, I am going to move this 4 to the right, to the left side. So x minus 4 equals negative 1 over 16 times y minus 5 squared. And now I'm going to move this negative 1/16 because we don't want to have a fraction in front of our squared thing. We want it to be on the other side with the non-squared thing. So we multiply by the denominator in order to get rid of it. So this in standard form is negative 16 times x minus 4 equals y minus 5 squared. Okay, now this is your standard form for a parabola, just like this. So some things that we can recognize. The first thing we have to do is find the vertex. So the vertex, the x coordinate comes from your x parenthesis. So a negative 4 in parenthesis is a positive 4 as a coordinate. And a minus 5 in your parenthesis becomes a positive 5 for your coordinate for your vertex. So we go 1, 2, 3, 4 units to the right, and 1, 2, 3, 4, 5 units up. Okay, so there's the vertex for our parabola. So the other two things we have to find are the focus and the directrix. Okay, so the focus is a certain unit away from your vertex, okay? And that number is found hidden in here. Okay, so to find your focus, you take 4p and you set it equal to negative 16 because p is the distance from your vertex to your focus. So for this parabola, we have a p-value of negative 4. Okay, now don't worry about negatives. Negatives will just mean we count to the left of our vertex. So 1, 2, 3, 4 means I have a focus here. Okay, 4 units to the left of your vertex, which means our directrix is 4 units to the right of the vertex because your directrix and your focus are always the same distance away, but on opposite sides of your vertex. So this directrix has an equation of x equals 8 as the equation of this vertical line. Now the last thing that we have to plot is this length called the lattice rectum. Okay, the lattice rectum is a line that is perpendicular to the focus vertex line here. Okay, so it's perpendicular and it tells you how wide your graph is going to be. Okay, also this negative 16 is important here. So if you take your 16 and you divide it by 2, that tells you the distance from your focus, from your focus to the point on the graph. Okay, so right here we only have a vertex and a focus. We don't have another point to sketch on here in order to figure out. Well, this factor here in front of your non-squared term is the length of your lattice rectum. So we divide it in 2 because it's always even, because it's wonderful symmetry with parabolas. So we count 8 units down, 1, 2, 3, 4, 5, 6, 7, 8. And we count 8 units up, 1, 2, 3, 4, 5, 6, 7, 8, and it runs into all my work. But that's fine because these are your other 2 points that are going to make your graph nice. Okay, it will tell you the width. So your lattice rectum tells you basically the width of your parabola. So this parabola is quite wide, right? It has a lattice rectum length of 16 units because it has a focal length of 4 units, and this is always 4 times as long. Okay, so that lattice rectum, even though it sounds hilarious, is a pretty important piece to this puzzle when it comes to sketching the graph of a parabola.